What if I told you the future of clean energy isn't just about shiny solar panels or giant wind turbines? What if it's also about something much, much simpler? Something you might find in your own backyard or in the walls of your house. I'm talking about bricks and rocks. Yes, really. It sounds almost too simple to be true, but some of the most brilliant minds in science are turning these ordinary materials into powerful tools for storing energy. This isn't a science fiction movie plot. This is happening right now, and it could change everything. We are on the verge of a revolution powered by things we've used for thousands of years. Think about it. We often look for complex, high-tech answers to our biggest problems. We imagine futuristic batteries made of rare and expensive materials, but the real breakthrough might be sitting right under our feet. The idea is to use common, everyday stuff to solve a very modern challenge: how to save clean energy for when we need it most. This isn't just a clever trick, it's a fundamental shift in how we think about power. It's about being resourceful, economical, and smart. The next time you see a simple brick, remember that it might just hold the key to a cleaner, greener future for all of us. This journey into the world of heat storage is incredibly exciting. We are taking the simple act of heating up a rock and turning it into a sophisticated system that can power our world. These are not your typical batteries. They don't use chemicals like lithium or cobalt. Instead, they store energy in the form of pure, raw heat. This makes them safer, cheaper, and much more sustainable in the long run. By embracing this approach, we can build a more resilient energy grid that relies on materials that are abundant, safe, and easily accessible to everyone, everywhere. It's science at its most practical and most impactful, so let's explore this amazing idea together. We will look at how a humble brick can become a heat battery, and how volcanic rocks can store enough energy to power entire factories. This is a story about innovation, but it's also a story about going back to basics. It's about seeing the extraordinary potential in ordinary things. It proves that sometimes, the most powerful solutions are the ones that have been hiding in plain sight all along. Prepare to be amazed by the incredible world-changing power of simple bricks and rocks. The future of energy is getting very, very hot. Renewable energy sources like the sun and the wind are fantastic. They give us clean power without creating harmful greenhouse gases. When the sun is shining brightly or the wind is blowing strongly, we can generate a huge amount of electricity. But there's a big catch. What happens when the sun goes down? Or when the wind stops blowing? The power goes away. This is the biggest challenge for clean energy. It's not always available when we need it. Our homes, schools, and hospitals need power 24 hours a day, 7 days a week, not just when nature cooperates with us. This is where energy storage comes in. Think of it like bottling sunshine or canning the wind. We need a way to capture all that excess energy when it's being produced and save it for later. When you have a big jar of jam, you can enjoy the taste of summer fruit even in the middle of winter. Energy storage works the same way. It lets us use the solar power generated at noon to light our homes at midnight. It allows us to use the wind energy from a blustery afternoon to power our devices during a calm morning. Without storage, a lot of clean energy simply goes to waste. For a long time, we've relied on lithium-ion batteries, the same kind you find in your phone or an electric car, to store electricity. These batteries are great for many things, but they have their limits. They can be very expensive, especially when you need to build them big enough to power a whole city. They also rely on mining for materials like lithium and cobalt, which can be hard on the environment and are only found in a few places around the world. We need more options. We need storage solutions that are cheaper, safer, and made from materials we can find almost anywhere. That's why storing energy as heat is such a game changer. Heat is a form of energy, and it turns out that some materials like bricks and rocks are incredibly good at holding onto it for a long time. Instead of storing electricity in a complex chemical battery, we can use that electricity to superheat these simple materials. Then, we can release that stored heat later to create steam, run turbines, or directly warm buildings. It's a more direct and often much more efficient way to use our clean energy resources, especially for big industrial jobs that need tons of heat. Let's look at how these amazing heat batteries work. One company called Rondo Energy has created something they call a brick toaster. Imagine a giant silo filled with thousands of ordinary bricks. When there is a lot of cheap, clean electricity available from solar or wind farms, that power is sent to electric heating elements, just like the ones in a toaster. These elements get incredibly hot, and heat the bricks up to a blistering 1,500 degrees Celsius, about 2,700 degrees Fahrenheit. The bricks absorb all that heat and hold on to it, acting like a giant supercharged thermal sponge. They can store this intense heat for hours or even days with very little loss. When a factory needs that energy back, the process simply reverses. Cool air is blown through the silo over the glowing hot bricks. The air instantly heats up to an extreme temperature. This superheated air can then be used directly to make things like cement or steel, or it can be used to boil water and create high-pressure steam. That steam can then spin a turbine to generate electricity or be used for other industrial processes. It's a beautifully simple and elegant system. It takes in electricity and gives back high-temperature heat, which is exactly what so many industries need to stop burning fossil fuels. Another brilliant company, Bren Miller Energy, uses a different natural material volcanic rock. Their system works on a similar principle, but instead of bricks, they use crushed rocks inside insulated steel units. These rocks are heated up to about 750 degrees Celsius, around 1,400 degrees Fahrenheit. The heat is then stored in these modular, container-sized units. When the energy is needed, water is piped through tubes that run through the hot rocks. The water instantly flashes into steam, which can be used to power industrial machinery or to generate electricity. It's like having a volcano on demand, but completely safe and controllable. The beauty of both of these systems is their simplicity and durability. Bricks and rocks don't degrade like chemical batteries do. You can heat them up and cool them down tens of thousands of times without them losing their ability to store heat. This means these heat batteries can last for decades with very little maintenance. They are built from cheap, abundant materials, making them a much more affordable way to store massive amounts of energy compared to lithium-ion batteries. They are turning our planet's most common materials into high-tech tools for decarbonization. The biggest impact of these new heat batteries is on industries that use a ton of heat. Think about making cement, steel, glass, or even food and drinks. These processes require incredibly high temperatures, which have almost always been produced by burning fossil fuels like natural gas or coal. This makes heavy industry one of the biggest sources of carbon emissions in the world. But with brick and rock batteries, these factories now have a clean alternative. They can switch from burning fuel to using heat generated by renewable electricity, dramatically cutting their carbon footprint. For example, a cement factory needs to heat a giant kiln to over 1,400 degrees Celsius. A Rondo heat battery can deliver air at that exact temperature, powered entirely by solar or wind energy. This means the factory can produce cement with far lower emissions. Similarly, a company that makes giant hot water tanks for hospitals and hotels needs lots of heat to manufacture its products. Bren Miller has installed its rock battery system at one such facility, replacing gas boilers. The factory now runs on clean heat, saving money on fuel and reducing its pollution. This idea of sharing heat is also being used to warm entire neighborhoods. It's called district heating. It's a modern idea with ancient roots. The Romans used it to heat their bathhouses. Today, a central heat battery, powered by renewables, could generate hot water or steam that is piped to hundreds of homes and buildings for heating and hot water. This is much more efficient than every single building having its own furnace or water heater. Companies are already planning projects in Europe and the United States to use these thermal batteries to create clean, affordable heating for entire communities. The economic benefits are just as important as the environmental ones. While solar and wind power can be very cheap when they are available, fossil fuel prices can go up and down unpredictably. By installing a heat battery, a factory can buy and store electricity when it's at its cheapest, and then use that stored energy around the clock. This gives them a stable, low-cost energy supply, protecting them from volatile fuel markets. It helps them save money, which makes them more competitive while also helping the planet. It's a true win-win situation for both industry and the environment. Of course, these heat storage technologies are not a magic bullet that can solve all our energy problems by themselves. They have limitations. The most important one is that they are best at providing heat, not electricity. While you can use the stored heat to generate electricity with a steam turbine, you lose a lot of energy in that conversion process. It's much more efficient to use the heat directly. This means thermal batteries are a perfect fit for industrial heat applications or district heating, but less ideal for powering the electric grid on a massive scale, a job where chemical batteries still have an edge. Despite these limits, the potential is enormous and growing every day. These technologies are moving out of the lab and into the real world at an impressive speed. Companies are building bigger and bigger facilities. What started as small pilot projects are now scaling up to industrial-sized systems that can store enough energy to power large factories for hours at a time. As more of these systems are built, the costs will continue to come down, making them an even more attractive option for businesses and cities looking to go green. We are at the beginning of a major expansion for thermal storage. The journey of these simple materials from the ground to the heart of our energy system is a powerful reminder. It shows us that innovation doesn't always have to be about creating something brand new and complicated from scratch. Sometimes it's about looking at the world around us with fresh eyes and finding new, ingenious ways to use the resources we already have. Bricks and rocks are ancient, reliable, and everywhere. By unlocking their potential to store energy, we are building a more sustainable future on a foundation that is quite literally as old as the hills. In the end, solving the climate and energy crisis will require many different solutions working together. There won't be one single answer. But the rise of brick and rock batteries proves that some of the most effective tools might be the simplest. They offer a way to make clean energy cheap, reliable, and accessible for the parts of our economy that are the hardest to decarbonize. By embracing the power of heat and the simplicity of rock, we can take a giant leap forward in building a world powered by clean, renewable energy for everyone. It's a solid foundation for the future.